the most important and significant scientists in the realm of electromagnetism is, well, you might be thinking James Clerk Maxwell, but it's also Michael Faraday. This guy has given us about a dozen principles and also instruments that have his name, like the Faraday's cage, or Faraday's constant, or Faraday's law of induction, or even a farad, which is a unit for capacitance. Today, we'll be learning about his most significant contribution, which is Faraday's law of electromagnetic induction. In this experiment, Faraday takes a coil and connects it to a galvanometer. Now, a galvanometer is basically an ammeter which measures small currents. He took a magnet and observed that when the magnet is at rest, there is no deflection in the galvanometer. He moves the magnet towards the coil and the galvanometer needle goes in one direction immediately. When the magnet is kept stationary at that point, the needle comes back to zero. Now, if we bring back the magnet, the galvanometer needle will again deflect, but in an opposite direction. And again, if it is stationary, the needle goes back to zero. And also, if the coil is moved from the magnet, the needle deflects. Now, any change in the magnetic environment of the coil will lead to a voltage or an EMF to be induced in the coil. No matter how the change in the magnetic field is produced, the EMF will be induced. To put it, whenever there is a relative motion between the conductor and the magnetic field, there is also a change in the magnetic flux, and this change in magnetic flux is what's causing the EMF. Faraday also observed that faster changes in flux through the coil led to higher EMF, and thus more current was produced. You can see it here, where when we move the magnet faster, we see more current, and when we move it slower, we get lesser current, which means lesser EMF is induced. This is Faraday's law. So the EMF will be change in flux per time, or E is equal to delta phi by delta T. Delta phi is the change in the flux, and in a coil, if there are n turns, then the flux will be phi is equal to n phi naught. So what have we learned in this video? We have seen what Faraday's law is, and also we have seen the equation for Faraday's law. So until next time, happy learning!